Welcome to qnawire.
Hello everyone, this is the solution to problem 5 of chapter 24 of college physics. And here we're asked to find or come up with an experiment that allows us to test whether sound waves can be polarized or not. So what we know about sound waves is that they are mechanical waves, which means that they do need a medium to propagate in, something like an elastic band or air or any kind of medium. So this is one of the crucial differences between light waves and sound waves, for example, where because light waves are allowed to travel in vacuum too. So our current understanding of sound waves is that they are actually longitudinal waves, which means that they create compressions and rarefactions that propagate in the direction of travel of the wave. So here, for example, in air, I'm trying to show air molecules as these little dots here. So here we have a region where there's a compression, so there's a lot of molecules, and then there is a rare region where there's barely any molecules, and then there's again a compressed region, and so on and so forth. And the wave is traveling in the direction of the arrow. So you can think about this also as a slinky, for example, where you have that the slinky strings are really compressed, and then they're stretched out, and then they're compressed again, and then they are stretched out again, and so on and so forth. And it's vibrating in this direction over here. So how can we test whether sound really obeys this model or if it's a transverse wave instead? In which case, the vibrations are perpendicular to the direction of travel. So again, if we think about the slinky, for example, then transverse slinky wave would be something like this, where you would have that the slinky is vibrating up and down while it's moving to the right, for example. So then let's try and come up with an experiment to test this. So what we're going to have is we're going to have a soundproofed room over here and a speaker in there, which is going to be switched on by us. And we're going to drill a long hole in one of the walls in which we keep the speaker. And then we're going to make these little solid materials or polarizers, quote unquote, which are just like solid blocks that fit into this tube in some way. So they have some width, like let's say something like this. And they have these narrow slits cut into them. So as you can see, this is like a full-on solid material that you're going to put in here. So these guys go in here. And then what you're going to do is you're going to first test that the sound is working. So you switch this on. Now it's on, it's producing sounds. It's coming out, and you're going to detect it at the end of this tube to see if you can hear anything. Okay, so you established that you hear something. Now you're going to put two of these polarizers in here, and first you put one in like this, for example. So you've got the first piece in here, and it's polarizing in this direction. So the slits are pointing vertically, and then you're going to put in the other one next to it or behind it, and the direction of polarization on this one is going to be into and out of the wall. So for those of you who are not familiar with this notation, you can't really see it anyway. So cross is representing things that are moving into the whiteboard, and dots are representing things that are coming out of the whiteboard. So that's the direction in the second polarizer. And so if these are pointing perpendicular to each other, so like I've shown them here, so you put them in this order, and if you can't hear anything on the other end of the tube or the tunnel, then you know that the sound is probably transversely polarized. The reason for that, or that it's a transverse wave, is because think about how the wave is vibrating, right? So if you have a slit that is pointing in this direction, and you have a wave that's coming in and it's transverse, then this polarizer is going to allow all of the components that are vibrating in the direction of the slit to come through the material. Okay, so then everything that comes out on this end is moving in the same direction as the polarizer's direction. So in this direction, right? So now it's coming like this, and then it comes, it becomes incident on the second polarizer, which is now perpendicular to that. So if you're trying to go through here and you're transversely polarized, then you realize that there are no components that are vibrating in the direction of this of the slit of the second polarizer. So you've got nothing coming out on this end. So by this analogy, if you do not hear anything out here, so if there's nothing out here, once you put this these two polarizers in this order and they're 90 degrees to each other, then you know that sound is probably a transverse wave. So what else can you do? Okay, so let's say that you produce some angle between the two polarizers such that you rotate this, for example, this guy by 30 degrees. Okay, so now what you have is, instead of this pointing in and out, it's pointing in some direction like this, let's say, right? And so now the wave is going to do the same thing as it did before. So it goes through the first polarizer, it goes through just as before, and now it's only the components of the wave that make it through that vibrate in the same direction as that of the first polarizer. And then it's going to become incident on this other one, but this is now making an angle with the first polarizer's direction. But now there might be some components of this wave that are vibrating, but now they're vibrating in this direction, the direction of the second polarizer. So anything that makes it through is the component that vibrates in the direction of the second polarizer. So if you rotate it, and you start to hear something here, there is some noise over here, then again, that's a good sign that sound may be transversely polarized, or it might be a polarized wave. So what else can you do? You can test if this relationship of the intensity of the sound that you hear here is obeying the relationship where you have this cosine squared of the angle between the two polarizers. And if that's true, then you can conclude that sound is transversely polarized. However, we know that that's not true. That's not what we find. And in fact, what happens is that you make the sound here, and it doesn't matter how you rotate these polarizers, you're always going to get some sound here. So I hope this helps. This is one setup that you can do to test if sound is